Ever wondered how a computer determines whether a list of numbers contains duplicate elements? This process, decoded by a simple algorithm, is prevalent in Python programming. Let's make a function for this called contains duplicate. Picture this: a diligent cowboy in the Wild West, responsible for gathering a group of numbers. Each number, akin to a wild horse, roams freely on the vast plains. Tasked with corralling these numbers, we call on this cowboy when we call on this function. His mission is to capture these numbers, or wild stallions, within an enclosure and see if any are the same. So, how does he go about it? Our cowboy commences with building an unblemished empty corral, akin to us creating an empty hash set. A clean slate, you may imagine. Symbolically, this corral is an empty hash set, embodying a special characteristic of Python, a hash set that only shelters distinct elements. Then our brave cowboy moves towards the initial number. With his lasso, he skillfully ensnares it, reeling it into his pristine corral. In a way, this mirrors the function's for loop. A loop which, akin to our cowboy's methodical approach, examines each number present in the list. He lassos it and brings it over to the empty corral. This is akin to the for loop in our function, which iterates over each number in the list. Now, here's where it gets intriguing. The cowboy, before introducing any number into the corral, has to verify if the same stallion is already present. This process is represented by the if statement in our function. The task of this statement is to cross-verify whether the number is already a part of the hash set. An event where the cowboy discovers a duplicate, he waves a flag making a true statement. This is the function's way of returning a true value, which signifies that there are duplicates in our list. This marks the end of the movie and the completion of the task. But what if our daring cowboy ventures through the labyrinth of numerical sequences, meticulously sifting through each and every one of the original set, without spotting any recurring figures or duplicates? In this scenario, our cowboy, with a resolute expression, unflinchingly hoists a flag. Upon this flag, the word false is boldly inscribed, a powerful testament to his unwavering resolve and his fruitless quest. This, in essence, mirrors our function returning false, an indication that there are no duplicate numbers present within our list. Once again, the curtain falls on our cinematic narrative, but this time the conclusion reveals a different, compelling outcome. So in a nutshell, the contains duplicate function in Python uses a hash set and a for loop to find duplicates in a list. This algorithm is versatile, used broadly in Python and beyond. It's employed in database management, data analysis, and many other areas where duplicate data is handled. Essential in both programming and data-centric fields, its importance can't be overstated. It's about wrangling numbers or wild stallions. The principles remain consistent. Until next time, happy coding. All right, partners, now that we've ridden through the theory planes, it's time to settle down by the coding campfire. Let's pull out our Python lasso and take a gander at the contains duplicate function in its full glory. In this Python code, we start by initializing an empty set called num_set. Then using a for loop, we go through each number in the given list. If a number is already in our set, that means it's a duplicate and we return true right away. If it's not, we add it to the set and continue. If we go through the entire list without finding any duplicates, we return false. Remember, just like our cowboy friend, this function is all about efficiency. It's a quick draw, able to identify duplicates in a single pass through the list. So next time you're in a coding showdown, don't forget to bring your contains duplicate function along for the ride. Until then, keep those coding spurs sharp.